Good day and welcome to today's class. In our previous class, we talked about rate expression. In today's class, we're going to talk about rate expression and stoichiometry. So I encourage you to watch the previous videos if you've not seen it yet. Let's take, for example, I have a reaction A to give B. Okay, the rate expression for this will be minus change in conc of A over change in T equals to change in conc of B over change in T. But let's assume I have a reaction like this, A to give 2B. This is quite different from this in the sense that the stoichiometric ratio of A to B is 1:1. But stoichiometric ratio here of A to B is 1:2. Normally, the rate of A is supposed to be equal to the rate of B, right? But now we're having 2B. B tells you that B is like 2 times of A, right? So I can say that the rate at which B is being formed is 2 times the rate at which A is disappearing or being used up in the reaction. Okay, similarly, let's say I have A, let's say A plus 2B to give 3C. If you look at this, you can see 2B is like 2 times of A and 3C is like 3 times of A. So I can say that the rate at which B is disappearing is 2 times the rate at which A is disappearing or being used up in the reaction. And the rate at which C is being formed is 3 times the rate at which A is being used. So if you're asked to write the rate expression, something like this, but for this kind of reaction, what is it going to be? Normally, what will be the rate expression? It's going to be minus change in conc of A over change in T equals to what? Change in conc of B over change in T. But now we have to account for these two. The way I like to think about it is if the rate of B is 2 times that of A, that means that the rate of A is half the rate of B. That's how I think about it. But how I think about it is this. Just in a simple way, just make sure that these 2 equals 1. And how can I make 2 to become 1? It's very simple. If I multiply 2 by half, what are you going to have? This cancel this, you have what? 1. All I have to do now, I have to multiply these 2 by what? By half. That means that in the parts where we have the rate of formation of B, I will add what? 1/2. Okay, let's spend that thought. Let us look at this other equation here. We have A plus 2B to give 3C. Again, what will be the rate expression? It should give us what? It should give us minus change in conc of A over change in T, right? Equals to what? Change in conc of B over change in T. But of course, there'll be a minus sign because if, the conc of B will also what? Reduce as the conc of A also reduces. And this is also going to be equals to what? Change in conc of C over what? Change in T. But now this is not very, very correct in the sense that we have a stoichiometric ratio of 2 with B. So what do? Make these 2 become 1. And I can do that by multiplying by 1/2. So what do I add here? Here I will add what? 1/2. Similarly, I have to make this 3 become 1 by doing what? Multiplying by 1/3. Simple maths. What do I add here? I will add 1/3. So in simple sense, this is the rate expression. This here is the rate expression for this reaction. Okay, let's see the reaction for the formation of water, where we have H2 plus O2 to give 2H2O. Balance the reaction, we have a 2 here. Now, what will be the rate expression for this reaction? First, what is the rate of disappearance of H2? The rate of disappearance of H2 should be minus change in concentration of H2 over change in time. Of course, it has a stoichiometric ratio of 2. So what do we add here? We add 1/2. This should be equals to what will be the rate of disappearance of O2. That should be what? Minus change in conc of O2 over change in T. And what will be the rate of formation of water? That will be what? Change, no minus sign because the conc is not reducing but increasing. Change in conc of H2O over change in T. But of course, because the ratio here is 2, we add what here? 1 over 2. I think this is quite clear. This is the rate expression for the formation of water.